In 1990, 5 years after having given up on the weird and wonderful PC Junior, IBM returned to the home market with a slightly less weird, but still wonderful IBM PS1. If you had bought one of these machines back in the day, you would probably have been pretty disappointed when it was time to upgrade your fancy IBM. Because this IBM has an SX25 soldered directly to the board, and no support for level 1 cache. It's fixed to 25 MHz and has no VLB slot. Luckily, we know how to hack this motherboard and make it really fast. So be prepared to be surprised. This ultra-slow IBM is going to play Doom when we're done with it. And it's going to play it really well. But there is a problem, of course, as so often on this channel. Before we can do any overclocking, we need to repair a power supply and sound card. Okay, let's start with the power supply. This is actually not the power supply from the machine that we are working on today. This is from the socket for IBM PC330. The reason why we need to fix this power supply today is because it's broken, and to be able to finish that PC330 video, I had to snatch the power supply from the PS1, because they are almost identical. And the usual disclaimer, of course, please don't poke around inside power supplies. They may contain high voltages, even with the cord unplugged. That being said, let's get inside and see if we can fix it. Well, it's been turned off for quite a while, but better safe than sorry. So, this power supply is completely dead, and it's making a very nasty high-pitched noise. Not the easiest power supply to work on, because it has the PCB mounted upside down, and pretty much nothing is accessible without taking that PCB out completely. It's still not quite accessible, so let's remove this switch here. So this is an international power supply with the switch at the back. Okay, I think this is good enough. So this power supply is making very nasty noise, and that noise is coming from this coil here. The reason why I gave up quite quickly on this power supply in that socket 4 video is that just to get access to all the components and troubleshoot this board, I would have to desolder this PCB here and desolder both of these heatsinks here, so it's a bloody pain to troubleshoot. However, a viewer left a comment in that video that in his experience the ticking coil usually means that one or both of the primary line capacitors has failed. And that's these guys here, and they are easy enough to check. So I ordered some caps, and maybe there is a chance we can make this power supply work again. So these large caps are 200 volts, 330 micro, and they actually have huge pins. So I may not be able to use my desoldering gun. No, that didn't quite work. Let's try the other pins. No, my tip is too small for these huge caps. Luckily, I seem to have a larger tip for my desoldering gun. So let's go ahead and replace it while it's still hot, because I don't like to wait for things to cool down. Okay, with that minor issue sorted, let's try again. I think it's still slightly too small, but I think it's working, sort of. Those pins are huge. Yeah, that tip is still quite not large enough, but it's sort of working, just not as intended. By the way, these are Nichicon brand, so I had no reason to suspect that these were bad. So first we need to cut that glue, otherwise we're gonna have to remove them both at the same time. So they are partially loose now. Yeah, this one is actually completely loose. This one not so much. I see, these are snapping. So how about if we bend this leg a bit? Yep, came right out. So it wasn't all that hard. Okay, the closest I could get are these 250 volt Nichicons. They should be 330 micro, and they are measuring 285. It's quite a bit off for a brand new cap. Okay, let's check these old caps. 300 micro. So these old caps are actually closer to the value they should have. Yeah, this one too, 300 micro. So how about the ESR? So these new caps are at 0.3 ohms. And these old caps are about the same. Let's check this one too. Yeah, that's about the same too. So my meters don't show anything wrong here, but I don't trust them entirely. So let's replace those caps. So these caps are slightly larger because they are rated for a slightly higher voltage. But this is the closest I could get. I have had a few caps that showed pretty good values, but were still giving me trouble. So just checking the values isn't quite conclusive to me. Well, I ended up ordering these smaller caps too. Let's start with this guy here. I think this board has 4 of these smaller caps on this side of the PCB. And of course it has bent legs. There we go. So this guy here is a 1 microfarad, 50 volts. We have another one of these further down the board. We checked some of the components in this power supply in that socket 4 video, but I don't quite remember what we checked. I think we tested some transistors or some voltage regulators. So these are identical. I got some replacements here. Let's do a comparison. 1 micro, pretty much spot on. And same thing with this old cap. How about this one? Yeah, that looks good too. So, how about the ESR? We've got 20 ohms. That is quite high, but it may actually be within specs. Let's compare with one of these caps. Well, this cap only has 3 ohms. So maybe that Nichicon is bad. It's sitting very close to that heatsink. So maybe they are getting a bit too much heat. I'm gonna bend them slightly away from that heatsink. Apparently I didn't clean up this board. I guess I'll make sure to clean up that flux this time. I like to unbend the legs when I'm soldering new components. Not that it's likely that someone is going to repair this power supply in the future. But who knows? So next up we have these two guys here. They are glued together, but I think we're okay because we can just remove them both in one go. I think it was in the PC Junior repair video. Both meters were showing good values. And yet replacing the caps fixed the problem. So at the moment I'm not quite sure how useful it is to check those values. Maybe my meters aren't good enough. I wish I had saved some bad caps. That way we could have done an interesting test. With my meters. Well, none of the caps are showing any signs of leakage. So let's check these guys. Okay, let's see what the ESR is. 2.7 and 5.7. That is a bit high, but it could still be within specs. Let's compare them with my new caps. These are 2.2 and 2.3. So let's find out if that makes a difference. So let's solder in these new caps and try this power supply out. Unfortunately, IBM had to cut some corners to make the PS1 cheaper than their flagship PS2. So if you're on the market for one of these, you're more likely than not to find one with a broken door. And same thing with this latch here that releases the cover from the chassis. By the way, I think this is probably the best looking IBM ever made. It's very square 90s, and these vent holes here look like the back of a spaceship. It's a really good looking machine. As I mentioned, this power supply is for the socket 4 machine, but we might as well test it in this machine, since it will fit in this machine too. Okay, everything hooked up. Oh, apparently the machine was turned on. I can hear the hard drive spin up, and I don't hear any coil noise. Huh. Let me connect the display. Yeah, it beeps. Let's turn that thing off. Oh no, it started to make that coil noise when I turn the machine off. I'm not sure if the microphone will pick this up. But something is still not quite right with this power supply. It's interesting that it disappears when I turn the power supply on. So with some load, that coil noise just disappears. And as soon as I turn the machine off, it starts to make that noise again. Let's turn the machine on and see if it works. It does. I guess I'll connect the keyboard and do another test. Okay, let's have a look inside here. Okay, the floppy is not connected, and we don't have a mouse. But that's not needed. Yeah, it seems to boot normally. Yeah, so that power supply is fully working, but as soon as I turn it off, it makes a nasty coil noise. Huh. So one of the components in that power supply seems to be marginal. Well, I'm going to reinstall the original power supply in this machine anyways. I guess I'll get back to that socket 4 machine in a separate video. Okay, let's see if we have better luck with the sound card. This should be an easy repair. So this is an ESS 1868F. These are pretty good cards, but unfortunately the previous owner did something really strange with this card. This card here has two large cuts in the PCB. So someone was using a Dremel and cut through these pin headers here and removed two of them, and in the process cut through these traces here. It's almost too stupid to be true, but it seems to me that he needed some pin headers and decided that those pin headers were worth more than this sound card. It sounds really nuts, but I guess at one point these cards weren't really worth anything. Apparently less than 2 pin headers. So let's fix this. Okay, I did an inspection here, and to get better access to these traces here, I think we're gonna remove these 2 pin headers. They seem to be cut away from the remaining pin header anyways. So these cards aren't expensive compared to how good they are. So if you're on a budget, this is a really good option to a proper sound blaster. So let's see if these pin headers came free. Yes, they did. So now we have better access to these traces here. Okay, I did an inspection here, and these traces here are going underneath the pin headers here, and I can't quite see where they are going. So I think I'm gonna have to desolder these pin headers completely. It's kind of funny how someone thought this was completely worthless at one point. Nowadays, these are worth repairing. Well, that goes for a lot of vintage PCs and cards. Okay, let's see if we're lucky, or if we need some hot air. I'm not using any force whatsoever, in case one of the pins is stuck to one of the through holes. I'm gonna do this off camera, because I can't see anything. Okay, the pin headers came off, and all the through holes look fine. So we're okay, but I'm realizing quite quickly here that this is not going to be a pretty repair, because these traces here, they are going directly to these through holes here. So we can't solder any bodge wires underneath those pin headers. Or maybe we could. Yes, I think I have a decent solution for this. So I'm going to solder these much shorter pin headers on the board. And then I'm going to install 2 very short rows of pin headers here. I'll show you in a second what the plan is. And I'm almost done here. Let's see if this plan worked. To keep the pins nice and straight, I used an ID cable. Since this row of pins here is separate, I can just pull it off. Same thing on this side here, although this one was a bit stubborn. Now we have access to those pins and those broken traces. It's still not going to be easy, but I think this is doable. And it's going to look okay, compared to running long bodge wires from the other side of the board to these pads here. So next we need a grinding pan. The battery in my grinding pan swelled up years ago, so I removed it and hacked it with a USB cable. So it's now powered directly by USB. I had to finish a project, and apparently I forgot to order a new one. But luckily it works just fine this way. Okay, I made a small mistake here. So this pad here is going to this pin here. So we need to have access to this pin as well. So I had to make this pin accessible too. So the next thing to do is to remove the solder mask. So we can solder a small wire directly to the trace here, to 4 of the pins, like so. Next I'm going to add a tiny amount of solder at the base of this pin here. Oh no, that just came right off. So this may not work. At least it's not going to be easy. Oh, maybe there is a simple fix for this. I'll straighten that pin up, and then I'll reuse that plastic piece that we removed and put it back on, but just partially like this. That should keep this pin from moving. This is going to make it more difficult for you guys to see, but I'm just adding a tiny amount of solder to the base of the pin. And then I'm going to grab a short piece of PTFE and solder to the pin, like so. Now we can route this wire to the disconnected pad. I'll add some flux to these exposed traces and prepare them with a splash of solder. I'm not sure they are large enough. This could be a problem. No, those traces are too thin to solder a wire to. So let's remove the solder mask further down, where we have a larger area of copper. Soldering this close to the pads, we need to protect them, because if we get solder on those pads, they are not going to make good contact in the ISA slot. I just realized we need to attach all the wires first, before we solder them to this side here. Otherwise it's going to be too difficult later. So I'm going to use the same method by attaching this plastic piece to prevent the pin from falling over. Add a splash of solder, then 4 wires. Okay, all 4 wires attached. It's going to be too difficult to cut them to size and strip them on camera, so I'm gonna have to do that off camera. All wires cut to size and stripped. Let's add some flux to these exposed pads. I guess I should pre-tin them. That should make the soldering easier. Okay, this wire should go to this pad here. This wire goes to this pad. This wire goes to this pad here. And finally, this wire here goes to this pad here. Okay, let's remove that tape and clean this mess up. I thought this was going to be a quick repair. It wasn't. But I think that spaghetti looks pretty good, compared to if we had routed longer wires to the other side of the board and soldered to the back of these pins. Let's make this even nicer. Let's take this plastic piece and make it thinner, like so. Now let's take these two halves and put them back on. And cover up my spaghetti here and make it even less visible. And here's the final result. I'd say it looks okay. Perhaps a bit too much work on an ESS card. I think this card is worth it. These are pretty good cards. They sound good, they don't have any weird issues, and they're easy to set up and use. Okay, let's have some fun with this motherboard and do some overclocking. This board is partially hacked already. The first thing we did was to add this extra chip here with VRAM, because this board came with 512K, but it had these empty pads here. That turned out to be a significant improvement, because the onboard graphics chip here is significantly faster than any ISA card that we have tried on this board. I think that included the ET4000. I don't know if it's hooked up to the local bus, or if it's just running at a higher speed than the rest of the ISA bus. This doesn't matter if you're just going to play Monkey Island on your machine, but if you plan to play around in Windows, that actually made a huge difference. We can go to much higher resolutions with that extra chip. We have also added 256K level 2 cache in these sockets here. The 486 soldered directly to the board here is an SX25. That is pretty much as low as a 486 will go. This extra socket here is for 487 Mathco, so we couldn't use it to upgrade that 486. So the next thing we did was to add this bodge wire here and connect these two pins here. And that disabled the onboard 486. With the onboard 486 disabled, we could then use the Mathco socket with a regular DX2. By the way, you don't have to add a very long bodge wire like I have, but I like to do my mods reversible and clearly visible to make life a little bit easier for the next owner of the board. Next up we tried an ODPR100. The ODPR100 is just a regular DX4, but it's running off 5 volts instead of 3.3. So then we ran into a problem with the BIOS. It didn't know what to do with the 16K of level 1 cache in the DX4. Being confused, it just turned all cache off. Level 1 cache and level 2 cache. Luckily, Major Tom at Ardent Tools helped me to hack the BIOS. So this BIOS here skips that level 1 cache test and leaves all cache alone. So this board now runs with the full 16K of level 1 cache and a 256K of level 2 cache. Needless to say, that made a huge improvement. As I mentioned, the Mathco socket can only take 5 volt CPUs. So next up we built one of these up. This is Scrap Computing's excellent socket blaster. It's a clone of a vintage interposer that was available back in the day. So this thing does two things actually. It lowers the voltage to 3.3 volts or 3.45. So we can now use this board here with a 5x86, but it still ran at the same speed as the DX4, because by default the 5x86 runs in 3x mode. So then we discovered this little jumper here. That jumper sets the 5x86 in 4x mode, and that took us to 100 MHz. This board doesn't have any jumpers to set the frequency, but let's increase it anyways. Okay, so next we identified this little chip here that sets the clock for the 486. Unfortunately, it wasn't obvious how IBM had set the pins high and low for this chip to set it to 25 MHz. I posted on Vogons, and user Thermal Wrong noticed that there was a few missing resistors on these two pads here. We checked for continuity, and sure enough, Thermal Wrong was in fact thermal right. These pads are connected to the little clock chip. So the only thing we need to do is to move this tiny little resistor to these pads here at R174 to increase the speed on this motherboard to 40 MHz. Only problem is this resistor is absolutely tiny, and I have a huge camera on top of the motherboard, but I think we can manage. Yeah, I think that's okay, but I can't quite see. So let's clean up that flux. Yeah, I think that's okay, but I can't quite see before I remove the camera. But let's check it. So we should have 330 ohms. Yes, that looks fine. So next we can install the socket blaster. Before we install anything in that socket, let's check the voltages, because I don't remember what CPU I used it for the last time. Okay, board is still running, so we didn't mess anything up. Yeah, that buck converter is a bit unstable without load, but it seems to be jumping around between 3.3 and 3.6. That's close enough for a 5x86. Okay, let's check the frequency. That is odd. It's all over the place, and it keeps changing. Something isn't quite right here. Something strange is going on here. I just had 80 MHz on what I think is the clock out on the clock chip, but now it's jumping around here too. I don't know what's going on here. I'll try to reboot a few times. Yeah, something is glitchy here. Unfortunately, I think there's something wrong with this motherboard. So I checked the voltages to make sure the power supply is okay. I put that resistor back to R176 for 25 MHz CPU and installed the DX266. Let's do a test. It does work. Okay. Let's try again with the keyboard connected. Let's check those errors. Hard disk, diskette drive A, and mouse. So all that is perfectly normal. Okay, let's check pin 12 on that chip that gives us the clock for the CPU. Oh, that is giving us weird readings. Okay, so that's not the way to measure the clock on that chip. Okay, I checked the data sheets. And this pin here is marked mClock 2. So from what I can tell, this is our clock out. But we're getting nothing on that pin. Okay, I checked the frequency at the socket. Now we're getting 25 MHz. So now I wonder, maybe my meter is going bad. Yes, it's definitely the meter is broken. I hope you saw that. It just showed 25 MHz. But I'm not measuring anything. Yeah, there we go again. So, this meter is shot. Okay, I replaced the battery in a multimeter. Let's try this again. Okay, we are getting 25 MHz at the socket. Now let's check pin 12 again. No, we can't measure the clock here. Okay, resistor moved for 40 MHz again. Let's try again. No, it doesn't seem to work. We're just getting garbage. Okay, let's see what it does exactly. Well, that doesn't look too bad. What's going on here? Yeah, we're getting roughly 40 MHz. Oh, maybe my multimeter won't go to 40. But I'm pretty sure I have used it to measure 40 MHz. But I guess I could be wrong. Well, the good thing is that the board is running at 40 MHz. So I suppose we're all good. Okay, 5x86 installed. Let's see if it will post. I think it does. It does post. Excellent. Okay, so I guess I'll plug that hard drive in. Okay, hard drive hooked up. Let's see if it will boot. Wow, that Unity really tricked me. I thought that board was broken. I have enough repairs already. I don't really need any more right now. I guess I need to buy a new multimeter. But which one should I buy? It obviously needs to be able to measure more than 40 megahertz. Okay, let's see if I can find any software to do some benchmarks on this hard drive. Okay, let's see what it will identify here. Okay, it's showing up as a 5x86 running at 159 megahertz. Oh, I just realized we have never run any of these boards at this speed. So this is a record for an IBM PS1. In our previous attempt, we were running the 5x86 at 120 because we had that jumper set to 3x mode on the interposer, but now it's running 4x40. Well, we know what that means. We need to run some Doom. Okay, here goes. Oh no, it crashed. That sucks. Well, I'm not giving up that easily. So I have swapped the RAM stick for a stick that has been tested at 120 MHz. I have also changed these jumpers here. They are marked Micro Select, and nobody seems to know exactly what they do. I have done tons of tests without being able to figure out what those jumpers are for. So the system is now running at 121 MHz. We're getting some really funny numbers here. This computer performs like a 564 MHz AT. Let's try again with Doom. No, that just crashed right away. So it's not the RAM that's holding this board back. Okay, next I decided to pull out the tower version of this PS1. So this machine here has an identical motherboard. It has already been hacked and tested at 120 MHz. Okay, let's start with a quick test and make sure everything is okay. Okay, this machine is still okay since we used it last time. Oh no, that stupid keyboard broke again. The IBM M2 that came with this machine is wonderful to type on, but they have some really bad quality issues. I have repaired this keyboard 3 times I think so far. Now the arrow down doesn't work anymore. And the rest of the keyboard works. Well, I guess I'll have to repair it the 4th time. What? Oh no, the space bar doesn't work anymore. Crap. Well, I'll go and grab another keyboard. Okay, here goes Doom at 120 MHz. If I remember correctly from the previous video about this tower, I think we're maxing out Doom here. We have a couple of more FPS than Doom actually needs at full speed. So this project is obviously already a win. Yes, I think I'm correct here. So I think we're running at 38.6 FPS. Before we hacked this machine, it was running at measly 10.5. So this project is a huge win already. But I want to make it go even faster. Okay, so I changed the jumpers and we're now running the 5x86 in 4x mode. So this board is now running at 160 MHz. I should probably also mention that 5x86 is overclocked now. It's only supposed to go at 133. Oh no, it got stuck in post. Oh crap. Luckily I've got 2 more of these to test. So as you can see, they are only made to run at 133 MHz. And I have never tried these beyond 120 MHz. But depending on your luck, these can go quite a bit faster than they are specified for. So let's swap that chip and see if one of these can go faster. Okay, 5x86 number 2 in the socket. Let's try again. I'm getting nothing on the screen. So that didn't go too well. Okay, 5x86 number 3 installed in the socket. Fingers crossed. Okay, it's counting up the RAM. Okay, it boots. Oh no, it hanged. So it won't boot. Crap. Yeah, completely hanged. No, it consistently hangs when I try to boot. But that is actually not a limitation of the motherboard, because these guys aren't supposed to go at 160. Sometimes they do, but apparently not the 3 chips I have. Okay, in that case, let's go for what these chips can do. I have added one more resistor, and this board is now running at 33 MHz. Fingers crossed. It's counting up the RAM. We've got a couple of errors. Yeah, that's for the mouse and whatever. Diskette drive, mouse, sound card and CD-ROM. Yeah, that's all expected, so we're all good. Okay, boots to Windows. Everything seems okay. So it's reporting 5x86 running at 133 MHz. And we're getting a score of 42.49. We might as well check the cache, since we are running these tests. Okay, RAM is good. Level 1 cache is good. And level 2 cache is okay too. So, let's try Doom. Fingers crossed. Okay. Can't see any issues so far. And it's running really fast. Obviously maxed out. Yeah, this looks stable. Well, I don't know if anyone else is messing around with these boards, or if it's just me. But this is a record for a PS1 running a 486 class CPU. At least to the best of my knowledge. But of course, if you have managed to get one of these boards faster... Oh no! We only got 2085 real ticks. That is actually a tiny bit slower than our record. Oh crap! This video sucks. So in our previous attempt we reached 38.6 when we ran the board at 3x40 at 120 MHz. And even though we're running at max speed for that 5x86, I suppose because of the lower speed at 40, we're only getting 35.8. Not a big difference, and it still maxes out Doom. But that is actually a few points slower than our previous attempt. Oh crap! I thought this board was gonna fly today, but apparently it doesn't. Okay, so this is probably not a limitation of these boards. It's just the fact that these chips just won't overclock well. But some of them do, so I guess I'll keep buying them until I can find a chip that will do 160. And I guess we'll try again. Okay, so the next step for this project here, I think would be if someone could redesign the socket blaster and add a crystal and a clock chip underneath here. There is plenty of room for it. That way we could run it at all speeds between 33 and 40 MHz, and beyond of course. An interposer like that would be an absolute game changer, not only for this project, but for all the motherboards out there that don't have jumpers to set the clock, and for boards that won't quite do a certain speed. I have asked for some help with this, and maybe one day we will have such an interposer. Hit the bell icon below and set it to all if you want to join me in the next video. And now is a good time to watch the video where we restored and hacked the PS1 tower that we just used. I will end this video by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get early access whenever possible. You can also support me with a like and a comment. If you are a regular viewer, consider subscribing to this channel. Thank you for watching, see you next week!